This video was created by the Benzodiazepine Action Workgroup at the Colorado Consortium as part of the Recovering from Benzodiazepines for Peer Support training course. To learn more about this course, please visit benzopeertraining.org. For more information about the Benzodiazepine Action Workgroup, you can visit us at benzoaction.org. In a very simplified way, this video explains how benzodiazepines impact the nervous system and body. Let's start by identifying the key players. GABA, gamma-aminobutyric acid, is a neurotransmitter that sends messages from one neuron or nerve cell to another. The message that GABA transmits is an inhibitory, slowing, quieting one. Essentially, GABA is the body's natural tranquilizer. Benzodiazepines are medications commonly prescribed for anxiety, insomnia, seizures, muscle spasms, and alcohol withdrawal. Common brand names include Xanax, Klonopin, Ativan, and Valium. Excitatory neurotransmitters. These send excitatory messages from one neuron to another, causing them to fire. They are necessary for normal alertness, memory, muscle tone, coordination, heart rate, blood pressure control, and a host of other functions. Glutamate is the main excitatory neurotransmitter. GABA receptors. These are located all over the body and contain the sites where both GABA and benzodiazepines bind to exert their actions on the nervous system. Neurons are influenced by neurotransmitters like GABA and glutamate, and relay messages between different areas of the brain and other parts of the nervous system. So, how do these key players work? Normally, GABA attaches to its binding site on the receptor, and this tells the neurons to slow down or stop firing. As a result, the brain's natural output of excitatory neurotransmitters is decreased, resulting in lowered blood pressure, slowed heart rate, less fear, and more calming, to name a few. When someone is taking a benzodiazepine, the benzodiazepine binds at its own unique site on the GABA receptor, also called the benzodiazepine receptor, alongside GABA. The presence of benzodiazepines is thought to increase the effectiveness of GABA. As a result, benzodiazepines enhance or boost the natural action of GABA, further slowing and quieting the nervous system. As a consequence, the brain's natural output of excitatory neurotransmitters is even more reduced. To have a properly functioning brain, a delicate balance must be maintained between the inhibitory effects of GABA and the excitatory effects of glutamate. So, in response to the presence of a foreign chemical, the benzodiazepine, the body adapts with a series of adjustments, trying to counter or overcome it and its effects. If benzodiazepines are taken long-term, these body adjustments can ultimately lead to tolerance and physical dependence. Tolerance means the original dose of the drug has progressively less effect and a higher dose is required to obtain the original effect. Physical or physiological dependence is a state in which the body has neurologically adapted or changed due to the benzodiazepines. Both of these, tolerance and physical dependence, set the scene for the withdrawal syndrome, where a reduction or removal of the benzodiazepine can result in withdrawal symptoms. Here's an analogy to further explain. Let's say the nervous system is a car. The major excitatory neurotransmitters can be thought of like pressing the gas pedal on the nervous system, speeding it up. When the car takes off speeding down the road due to the nervous system being excited, GABA, as the main inhibitory neurotransmitter, functions as the brakes to maintain balance, to calm and slow it down. When benzodiazepines are present, there's even more braking that occurs because, as you'll recall, benzodiazepines enhance the natural slowing action of GABA. To counter this, the body then increases its output of excitatory neurotransmitters to maintain the speed of body and brain function, allowing the person to remain awake, alert, and functioning. Now, if that same person suddenly stops a benzodiazepine that has been taken regularly or reduces the dose too quickly, there is a sudden shortage of the body's natural calming GABA. And the excitatory neurotransmitters that previously increased to counter the benzodiazepines and GABA boosting are left suddenly unopposed, leaving the nervous system really overexcited. Because of this, withdrawal symptoms occur. frequently including symptoms like increased anxiety, panic, agitation, tremors, insomnia, muscle spasm, fast heart rate, and seizures, to name a few. And sometimes called rebound, an original symptom that benzodiazepines were prescribed for, like anxiety, for example, can reappear, but often with greater intensity than ever before. And new symptoms, never experienced before, can emerge too. These symptoms can continue for months and even years after benzodiazepines are discontinued. The science is still out on why symptoms sometimes persist for such a long time. One hypothesis is that the benzodiazepine changed or restructured the GABA receptor in some way. Perhaps the body reduces the number of GABA receptors in an attempt to counter or hinder the amount of benzodiazepine binding and subsequent GABA-boosting effects. Or maybe the binding sites on the GABA receptors become altered or even damaged. Whatever the source, these changes may take a long time to reverse after the benzodiazepine is removed. So the receptors are essentially stuck in some way, being less effective at utilizing GABA. This leaves the body in a chronic state of decreased GABA inhibitory function and increased nervous system excitation. In summary, the important take-home messages are: after prolonged exposure to benzodiazepines, the nervous system may not return to its pre-drug state for some time, taking months or even years for some people. Even if benzodiazepines are reduced by the recommended slow taper process, some individuals still experience painful symptoms which can persist long after stopping. And these symptoms are often described by those experiencing them as much worse than the original condition for which the benzodiazepine was prescribed. The entire experience can be incredibly distressing, so much so that suicide may be a risk. As a result, those enduring it require ongoing support from knowledgeable medical providers, family, and peers. While benzodiazepines can be appropriate and effective for certain medical situations, mostly when used intermittently or very short-term, long-term use can and does cause physical dependence with potentially long-lasting, life-altering effects. Please consult a knowledgeable medical professional with any concerns. For more information on benzodiazepines and their effects, visit the following resources.